For this lesson, we talk about a very important property of square matrices called the determinant. Determinants help us in solving the area of any triangle, solving systems of linear equations if it has a unique solution, finding the inverse of a non-singular matrix, and even changing the variables in multiple integrals. Later, we will see how we solve systems of linear equations using determinants. But first, let us solve the determinants of 1 by 1, 2 by 2, and 3 by 3 matrices. The determinant of a 1 by 1 matrix whose only entry is A is the entry itself, A, and we write it in this way. For example, if we have this 1 by 1 matrix whose only entry is 2, then the determinant of that matrix is 2. Or if we have the matrix whose only entry is -3, then the determinant of that 1 by 1 matrix is -3. Do not mistake our notation with absolute values. What we mean in this notation is the determinant of the matrix whose only entry is 2 or -3 in this case. Now how about if we have 2 by 2 matrices? The determinant of a 2 by 2 matrix A, B, C, and D is AD minus BC, and we write it in this way. So the determinant is the product of entries on the main diagonal minus the product of the entries on the off diagonal. For example, suppose we have this matrix 1, 2, -3, 0. Then the determinant of that 2 by 2 matrix is first, we get the product on the main diagonal, 1 times 0, minus the product of the entries on the off diagonal, -3 and 2. And if we simplify, we have 0 plus 6, or simply 6. Another example, let us consider this identity matrix of size 2. Then its determinant, first we get the product on the main diagonal of all the entries on the main diagonal, so we have 1 times 1, minus the product of the entries on the off diagonal, 0 times 0. And if we simplify, we have 1. Now let's move to 3 by 3 matrices. The determinant of a 3 by 3 matrix, we label the entries in this way, is given by this formula. So how do we memorize this formula? For the first term, we get the product of the entries on the main diagonal. Well, for the second term, we move to the diagonal after the main diagonal. So we have b times n, and then we don't have an entry here, so we go to our first column. So in this case, it will be bn times x. And then go to the next diagonal. After that second one, we have c times l times y. Minus, let's now go to our off diagonal, x times m times c. And then go to the right, we have y times n times a, plus, go to the next one, we have z times l times b. Let's have an example. Let's consider this 3 by 3 matrix. And let's get its determinant. So first, let's go to our main diagonal. 1 times 0 times 2, that is 0. And then go to the right, we have 2 times negative 1 times negative 1. That is plus 2. Then go to the right, we have 0 times negative 3 times 1, or simply 0. And then for the off diagonal, starting on the off diagonal, we now have minus. Then our off diagonal is negative 1, 0, and 0. The product is 0. Go to the right, we have 1 times negative 1 times 1. That is negative 1. And lastly, we have 2 times negative 3 times 2. That is negative 12. So if we simplify, we have 2 minus negative 13, or simply 2 plus 13. That is 15. Another example, let's consider this identity matrix. The determinant of the identity matrix of size 3. So first, we go to our main diagonal, 1 times 1 times 1, that is 1. To our right, the product is 0. Move to right, you have 0 times 0 times 0. So we have here 1 plus 0 plus 0. And then minus 0 plus 0 plus 0. And if we simplify, we have 1. In general, if we have an identity matrix, the determinant is always 1. As an exercise, try solving for the determinants of the following 2 by 2 and 3 by 3 matrices. Before discussing a method of solving determinants for square matrices of higher sizes, we first learn how to use determinants in solving systems of 2 or 3 linear equations on part 2.